Arati Prabhakar has spent her career investing in world-class engineers and scientists to create new technologies and businesses. She began her career as a congressional fellow at the Office of Technology Assessment. She then joined DARPA as a program manager, initiating programs in advanced semiconductor technology and flexible manufacturing, and was founding director of the DARPA Microelectronics Technology Office. In 1993, she was appointed director of the National Institute of Standards and Technology by President Bill Clinton. In 1997, she moved to Raychem, where she held a number of senior management positions, and then joined Interval Research as its president. From 2001 to 2011, she was the principal with the U.S. venture partners in Silicon Valley. In 2011, she was appointed by President Obama to lead DARPA. Is it 2011 or 2012?
12.
12, yeah, there's a mistake here. That's when it's, yeah, so a year ago. Ms. Prabhakar earned a Bachelor of Science from Texas Tech University and a Master's in Electrical Engineering and a PhD in Applied Physics from Caltech. She served on the National Academy's Science, Technology, and Economic Policy Board, the College of Engineering Advisory Board at UC Berkeley, and the Red Team of DARPA's Defense Sciences Research Council. She also chaired the Efficiency and Renewable Advisory Committee for the Department of Energy. She's a fellow of the Institute of Electrical and Electronics Engineers, IEEE, a Texas Tech Distinguished Engineer, and a Caltech Distinguished Alumna. And with that, please join me in welcoming Ms. Prabhakar to deliver her speech.
Thank you. Yes, I think I'm on. Go ahead. Yeah. Hello, everyone. It's great to be here. Thank you so much for the chance to join this group and to share with you some thoughts about DARPA and where we're going. I'd love to start by finding out who knows about DARPA. Great. Who's ever worked on a DARPA contract? Fantastic. Thank you. We don't do anything in our building, so thank you very much for what all of you have done. What I'd like to do is give you a little bit of a perspective on how we're thinking about our mission, which has not changed since we started in 1958, but how we're thinking about it in today's world, which has changed and changed and changed since 1958. And you know, really our story begins with what we were created to do. Obviously, the instigating event that led to DARPA's start was the launch of Sputnik. It was a technological and a strategic surprise for the United States. And the clear mission when DARPA began was to prevent that kind of surprise in the future. DARPA rapidly realized that the best way to prevent surprise was to create our own, and so for the last 55 years, that's what we have done. And the world today is filled with the technologies and capabilities that DARPA started. In every one of these cases, we planted the early seeds, made the pivotal early investments. In none of these cases did we do the job single-handedly because, of course, it took immense investments and effort on the part of private companies as well as the military services and agencies to really bring these capabilities to fruition and to use. But in aggregate, when we look across what we've been able to help bring into the world, it's a legacy that we're very proud of, and it's something that we see across many aspects of military capability, but also where we see much more broadly enabling technologies that are critical for national security, but also have played important roles in our broader economy and in our broader society. And you know, if you look carefully at these lines, especially if you look on top, you'll see that in many instances, in most areas, DARPA does not stay in one field forever. Navigation is a really great example where some of the very early work, when Sputnik was launched, there was a satellite, people started recognizing that you could use it for location and eventually for navigation. So some of the very, very early work that preceded GPS, DARPA was part of sponsoring. After many decades, DARPA returned to this field, recognizing an opportunity to shrink GPS receivers from in the 80s, in a period when they were big, bulky boxes, shrinking GPS receivers down to a cigarette pack size. That was part of enabling GPS to be embedded into lots of military systems, including precision weapons. It's also what started GPS receivers on a path to shrinking so small that they're now not even their own separate chip in my smartphone. And then today, after another long hiatus, DARPA has returned to this area because GPS, this is a great example of what often happens with these great capabilities that come from DARPA's early investments. Over time, GPS has become something upon which we are so reliant that that reliance in itself has become a vulnerability. And so today we are investing in position navigation and timing technologies to try to create the next generation of capability out beyond GPS so that we can get beyond this reliance on this phenomenally effective system. And that story is just one of many on this chart. In the enabling technology areas, of course, we're most famous for having made the first investments in ARPANET, which led to the internet. But really, that's only one aspect among many across information technology. Material science is a field that began with some of the early investments from DARPA, became a discipline out of those early investments, and we've continued to invent new classes of materials through our work. A number of interesting efforts in microelectronics and many other areas. All of that is history, and it's helped change the world that we live in today. But you'll notice that all of those bars stop in the middle of this decade, and the future is the story that we get to write in our generation at DARPA, and our challenge is to make the investments today that lead to the next generation of transformational technology capabilities for the future. DARPA has made this kind of lasting impact, not just in one decade or another decade, but over and over and over again, despite the fact that we're actually quite a small portion of the total R&D investment that's made in the Defense Department. The total bar that you're seeing here is the Defense Department's research, development, test, and engineering budget. The red portion plus the DARPA portion is the science and technology component. So you can see that DARPA is about a quarter of that piece. But just for reference, this total bar is about 20% of what our nation spends on research and development, both public and private combined. So any way you slice it, this DARPA component is a small element. It's sufficient resources at about $2.8 billion today. It's sufficient resources for us to make the investments in the highest priority, high impact, disruptive areas, but it's not large in this overall context. I think a key part of that success has been the fact that the nation and the department and Congress have supported DARPA very, very consistently. You see about a decade here, but that track goes back for many, many decades. And in good times and in bad, we've been fortunate to have the strong support from the public and all of our constituents because that steady support is really necessary for the kinds of long-range things that we do. So a quick snapshot of DARPA today. We're about 210 government employees. 95 of my folks are technical program managers, and as you'll hear, they're very much the core of the organization. The budget in 2012, which is still the last budget we had, is $2.8 billion. That budget is invested through a set of programs, about 250 distinct programs managed in 5 different technology offices. And through those programs, the resources ultimately flow to about 2,000 individual contracts and other agreements with a very broad technical community. And that community includes, as you might expect, major defense contractors, but it also includes small startup companies, some of whom think they're in the defense business and others who really think of themselves as being purely commercially focused. We work with universities of all stripes, and they're a very important part of our research endeavors. We work with other parts of the Defense Department, science and technology community, the DoD labs, but we also work with other government agencies and FFRDCs. And really, we are not an institution, we are a projects agency, but of course we can't really succeed in our work that is project-focused without being able to draw across this much broader set of institutions that constitute the nation's R&D capacity. Um, e- Everything that we do at DARPA really traces back to our mission, and we usually think of it in terms of creating and preventing strategic surprise, decisive surprise that changes outcomes. That's really what matters in the end for us. I had the unusual experience after I had come on board at DARPA last summer. Someone gave me a copy of my position description. And, you know, I've had a lot of jobs by now, and so I've read a lot of position descriptions, and I've written a few. And has anyone ever read a position description for a job that they had and thought that it actually said anything worth a bucket of warm spit? I hadn't either. But then I read my position description, and it's fantastic. And among other things, it says that DARPA's job is to anticipate, explore, and achieve the concepts and technology on which the nation's future deterrent and defense capabilities depends. And when I read that, I thought, I don't have time to be mucking around with this position description. I flung it down and I got back to work, because this is a mission that we take very seriously, and it's what sends, you know, me and my program managers all running through the door every morning to go to work. How do we translate this into action? It starts by thinking through 3 broad objectives that I believe derive from this mission. The first is to create breakthrough capabilities for national security. The second is to catalyze a highly differentiated and capable technology base for the United States, because that is so essential to our national security objectives. And those first 2 objectives are external deliverables. That's what we need to give to the country. But the third objective is something that's also important to us as an organization, and that is to keep DARPA itself a robust, healthy, vibrant organization, because that's going to help us deliver on our mission. But it's also important to us that we leave the organization in that state for the future generations that come after us. We're pretty sure that the world's going to be a complex place, and this country will need what we do for the future. So we also think about that. Now, everything on this slide, I believe if you had shown it to any one of my predecessors over 55 years, they would have nodded in recognition and agreed, because these really are the lasting notions about what DARPA's job is. But in fact, each of my predecessors and I have to think through how we do this job given the world that we live in. When DARPA began in 1958, of course, that was a time when we thought, the United States thought about our national security landscape in a way that was completely dominated by a monolithic existential threat that we faced. It was a time in which it's hard now to cast our minds back to the technological state at that time, but 1958, just as an example, was the year that the integrated circuit was invented. And this cornucopia of technologies from information technology on up that we live in today had not, that whole cycle really had just barely begun. Many changes later, we live in a very different world, a world of different complexities, and a world of different technological capabilities and new opportunities. And so really today our job is to understand this mission, these objectives in the context of this world. So let me tell you a little bit about how we're thinking about that, and I'll start with our first broad objective, which focuses on new national security capabilities. And I think we could spend hours talking about the national security landscape for our country and what lies ahead in the decades to come. But to step back and to think about it in an aggregate way, I think what really has struck us is the complexity and the change that we see across the globe. The actors who are engaged in the global security landscape range from nation states to groups, including terrorist organizations, to individuals, to criminal actors, with an interesting interplay among those parties. These actors have access to conventional weapons, but also to weapons of mass destruction, which themselves are changing in interesting ways, and also to new kinds of capabilities, including cyber threats, that become new tools in their hands. That's a world that, in many ways, it looks very different than the Cold War era in which I previously served at DARPA, as an example, or at the time of DARPA's founding in 1958. But in fact, I think the world has always been extremely complex. It's just that at that time we lived in an era where that complexity was overshadowed by a monolithic threat. And in many ways, the world we live in today has, a lot of things are better, but the fact that that one monolithic threat is does not loom quite as large really reveals to us, I think, the number of other possibilities that could lie ahead. And this is not a world in which it's possible to plan for and build solutions for one specific scenario. It's pretty clear that if you were to choose one, you would be making, you'd be guaranteed that something else will happen. Now, historically, we did build the vast majority of our national security systems, our defense and military systems, for a specific scenario. It was a Cold War scenario, and fortunately, it did not come to pass. We subsequently adapted those solutions for the challenges that we did face, or arguably those investments became part of the deterrent that caused those horrible events not to happen. But I think the environment we live in today actually calls for a little bit different thinking about the future and its complexity and lack of predictability. So that's number one. Number two, we live in a town that is abuzz with the talk of sequestration and continuing resolutions. We at DARPA are not immune from those problems, and we are participating in the budget cuts. My folks are participating. We'll have to participate in whatever furlough eventually comes down through the department. We are managing as best we can through that. But in fact, that's not what I'm talking about when I talk about budget issues. What I'm talking about really is the much more fundamental question about what we as a society will choose to invest in our national security in the years and decades that come ahead of us now. And I think it is possible, given our shifting economic position globally, given demographic trends, given the rise in healthcare costs and other pressures on the budget and public desires, that we may have a future ahead of us in which we do not have the kind of resources to provide national security, to keep our country safe, that we have historically had, and yet our job is still to keep the country safe. And I think that, too, is going to require some new thinking. So what are we doing about all of these issues that we see out in the world? I'll give you some examples, but the key themes, first and foremost, DARPA has always and will always invest in game-changing military systems concepts. That's where stealth technology came from. That's where the early investments were made in UAVs and many of the other technologies I mentioned in my first slide. So that will always be a core element of what we're doing. We want to add some new approaches to this list, though, and one of them is really a recognition that while every one of our systems programs at DARPA is trying to change a specific scenario. So if we're working on an advanced missile technology, we think it will change an outcome in a particular setting with a ship facing a challenge. If we're working on a new aircraft technology, we think it will win in this particular scenario. But really the question that we need to be asking is not just about those specific situations. It's really about how we transform warfighting for the next generation. And how that happened in the last generation was not through any one particular silver bullet of capability. It was through the layering of many technology vectors. And so if you look today at how we fight when we're in an active war, that happens through the combination, learning how to use stealth technology effectively, how to use global positioning to change precision strike, but also to change how we operate with our forces on the ground. Combining those ideas with deep communications and networking, adding to that UAV capability. That defines how we fight today. It's a big step forward from where it was in the generation before, but then the question is what's the next step that we can create? And when you start thinking about what's possible with position, navigation, and timing beyond GPS, with cyber capabilities, with advanced aircraft technologies, with the opportunities to combine manned and unmanned systems and advanced robotics, and you start thinking about how we can combine these capabilities, I think you can start imagining how warfighting could be transformed yet again in a way that shifts the burden of response to a future potential adversary, which is really, that is fundamentally our job. So one of the experiments we're doing is thinking in these multi-technology layered concepts about how we can make those big steps forward in capability. A couple of other themes. One has to do with adaptability. This is just another way of recognizing that we don't know precisely what challenge we'll face in the future, and whatever that challenge is in the future, when an engagement occurs, we know that our adversaries will adapt in real time, as they should, and we want to be able to adapt more quickly and outpace them. So adaptability at a much more fundamental level than we have in today's systems is something that we are striving for. And then finally, DARPA is, in some senses, the vanguard of the high-tech community that has come up with very powerful, but sometimes exceedingly exquisite solutions, and sometimes very costly solutions to the challenges that we're addressing. And I think we as technologists in our community have tended to glaze over when we talk about affordability. I've never found that to be a scintillating conversation myself, and I think we tend to think of it as something that someone else's problem will be brilliant, and then someone else will figure out how to make it all be affordable. I think it's time that we really challenge ourselves as a community to understand how innovation can fundamentally and dramatically change the cost equation. How can we come up with concepts and systems approaches that are modest to implement in cost and complexity, but which are very, very challenging for our adversaries to react to? How can we flip that equation around? I don't know the answer to that question yet, but I think it's something that if we can unleash the creativity in our technical communities, that I believe is going to have to be part of the answer to how we deal with our national security challenges in the budget environment ahead. Let me give you a few examples of some of the new thinking that's coming out of DARPA programs in these areas. And I'd like to start with what's happening in the cyber domain. Again, this is, in some senses, this is a new domain of conflict and of concern, where we're worried about protecting our systems and also thinking about what we need to be doing to engage with the rest of the world. And ironically, of course, this in some senses, if we hadn't started down the path of the kind of networking that goes on around the world, we wouldn't have these problems. So you could argue they're high-class problems. Nonetheless, they are really problems. Like every other area where DARPA focuses, we are not the people who are the operators who are going to go, who deal with the daily issues of cybersecurity, for example, or cyber offense. That's not our job. Our job is to ask about the capabilities that might change the dynamic from the one that we're struggling with today to a really different scenario. And we have both a vision and some specific programs, both in terms of how we think cyber defense and cyber offense can change in some dramatic ways. So let me start with cyber defense. I would characterize what we're doing today in cyber defense as really a patch and pray approach. We're very vulnerable. Our hackers who attack our systems are creative, and they can scale their attacks pretty easily. We're simply in a reactive mode trying to plug all the holes. And we have to run as fast as we can and keep trying to do that. The DARPA question that we posed to ourselves was, can we change that dynamic and get out of this patch and pray kind of mode? And we think the answer is yes, and we're attacking it in a couple of dimensions. One is to think about some fundamentally new ways that we might be able to create inherently more secure systems in the future as we build new capabilities and technologies. Thinking, for example, in that area about how we might scale formal methods that give us a mathematical certainty and a proof of functionality for a new system that we're building. Those of you who work in that area, of course, know that that's been limited to very, very small units of work, and we're looking at some ideas that might scale formal method approaches much more broadly. We're also thinking about what we might do the techniques that we can bring to bear that would help us understand how to deal with legacy systems with which we will be living for a very long time before this whole potential new wave of more secure capabilities comes down the pike. And we have some creative thoughts about that. Taken together, we can imagine a future in which cybersecurity it will never go away as a problem, in my opinion, but I believe it can be something that can be brought under control and managed in a way that gives us an assurance of operations that can last through attacks and continue to function. And that's where we are trying to take that entire conversation. Switching to the other side of this chart on cyber offense, today, cyber offense capability is something, it's a fine handcrafted attack that's used very, very rarely and only with the highest levels of authority behind any decision to employ that kind of a capability. But, we all go to the movies, and our adversaries go to the movies too, and they and we can imagine a future where cyber effects are an integral part of warfighting and completely linked to the kinetic aspects of warfighting. And we think it's pretty important that we figure out how to play that game and give those capabilities in a really structured, well thought out way to our operators and warfighters, because we don't want to be the ones that are reacting when that becomes how war is fought in an active engagement. So we're imagining a future where cyber effects become integral to warfare. Think of cyber effects the way we think currently about electronic warfare and how closely integrated that is to the kinetic fight. That means changing how cyber weapons are created. It means building structure around them so that we can actually predict and then measure the effect of deploying these weapons as we do with other weapons. And then finally, it means creating a structure around who's allowed to employ them so that we can build rules of engagement for these kinds of tools as we have for other kinds of weapons. That future is one that we think is coming, and we think it's imperative that we define what that looks like and get there first. And this is the picture that we're trying to paint. And when we talk with people in the military services who have to live in that world, this is, the work that we're doing here, I think, is something that really resonates with that community. Let me shift gears and tell you a little bit about some next generation stories in the area of position, navigation, and timing. I framed this previously in the context of how we live beyond the era of GPS. And this is this is only one project out of a handful of programs that we're looking at in position, navigation, and timing. But I think it'll give you an example that's an interesting one of how we're trying to move capability forward. This program started by recognizing that there were some there's some beautiful physics that's turned into some beautiful devices in terms of these hemispherical resonators, essentially a wine glass-shaped resonator that's very precisely manufactured. This is what's used on spacecraft. It's an expensive but extremely beautiful gyroscope system. We wanted to take that same physics and shrink it down with the micromechanical techniques that are more readily available today. We wanted to shrink it down from sort of a shot glass size that you're seeing here on the far right to really a millimeter scale hemispherical resonator. Now, when we do that, we lose a little bit of performance, but what we end up with is something that is still far more high performance and much smaller than the kinds of systems that are currently widely deployed in our weapons. So if you look up here where it says JDAM, you'll see something that's more the size of an apple. We have a way to get higher performance shrunk down to the size of an apple seed. And on the left side here, you can see these micro-machined small hemispherical resonators, and even the packaged device sitting on that fingertip is really quite small. So you start to see a future where very, very precise, very accurate, very high performance capabilities can be shrunk, can be reduced in cost, and can be brought from large platforms to handheld and embedded applications. And when we start to do that over time, I think we can layer these capabilities together in a way that allows us in military systems, but also in our commercial and personal lives, to start moving from an environment that has become very, very reliant on GPS to one that is able to live without GPS, and then ultimately to have a whole host of new applications and capabilities that are possible because of this enhanced PNT capability. A final example on the military systems side would be some of the work that we're doing in space. Phoenix is a program that is trying to tackle the immense cost of putting a geosynchronous satellite up for a new capability for communications, for example, that we might need. This program started with the observation that we already today have a number of retired satellites that are sitting at GEO that already have a lot of components, sometimes big bulky components like apertures. And I'll play this video while we're talking and you can see the picture. And the thought in this program was to create a satellite capability that would let us cooperatively approach one of these retired satellites, identify an aperture or other major asset that could be harvested from that satellite, and again, working in cooperation from the ground with the other party. Our satellite would approach with its robotic arm, would lock onto this dead satellite, and harvest the aperture. Just go up there and cut it off and use it. Combine it with satlets, small loads that were sent up separately, and essentially have a do-it-yourself, build your own GEO satellite at GEO orbit. And it's obviously this is an artist's conception. We're hoping this is going to become reality. The dream here is that if we can master the many technical complexities, that what we'll have is an ability to dramatically change the cost barrier to getting a new geosynchronous capability up in orbit. And there it goes. It's so easy when you're just making videos, let me tell you. Now, this program is an interesting example of a place where we recognized very early that, listen, if you're going to approach a satellite in space, this is a very big deal. We're talking about going right into the heart of a number of pretty touchy space policy issues. Our program manager, Dave Barnhart, set out from the beginning to engage not just the U.S. space policy community, but the global space policy community. So we're running a major unclassified program here. We've actively reached out to and engaged space policy actors from around the world. Dave recently spoke at a United Nations meeting that was grappling with these kinds of issues. And our hope here is that we can be part of not just building this capability, but also of setting the standards and the techniques and the ways that we globally deal with space as a global commons. Let me shift gears to the second topic, the second of my three objectives, which is to catalyze a differentiated U.S. technology base. That's been such an important part of how we create national security, and we think that it really has to be another cornerstone going forward as well. But of course, some of the things that in the environment that we're living with are the same as they've been for many, many decades, and other aspects are new. What I think is not changed is a virtuous cycle that has developed in many, many technology areas between defense needs on the one side and commercial opportunities on the other. And I'll tell you the story from the semiconductor world where I've spent a number of years, but I think it's a story that has played out in many other industries as well. Many times the needs of defense systems are a driver that get a big snowball rolling, and that certainly was the case in the semiconductor industry, where a lot of the early work in miniaturization for defense systems was a driver behind integrated circuit development and then some of the early products. So when those early investments happen, quickly, when there are big commercial opportunities, entrepreneurs and existing companies see what's possible, and they start piling private capitals, in this case, massive amounts of private capital over a long period of time, to build out those technology capabilities, build products, build companies. And this is great for the Defense Department because when that happens, it means that first there's a huge private investment driving a technology area from which we can benefit. Secondly, industries develop that are vital, robust, healthy industries that we don't have to directly support. They're there driving commercial markets, and that's a phenomenal benefit to us. And so in the semiconductor industry case, of course, over many decades, that has now grown to be about a $300 billion a year market, commercial market largely. DoD, which was once virtually 100% of the market for that industry, is now 1% of the market. And there are many good things that have come out of that. What's a very natural part of that process is the globalization of these kinds of industries. And again, in the semiconductor case, that's happened. Only about half of today's global semiconductor revenues are generated by US-based companies. That's, I think a lot of people would consider that a fairly healthy percentage right now. And even a larger share of our production for global semiconductors is done not in the United States, mostly in Asia. And in fact, today we have systems, major defense systems that rely on advanced semiconductor technologies that simply aren't manufactured in the United States anymore at all. So that comes, of course, with some vulnerabilities, assurance of supply, but also concerns about supply chain vulnerability. And those are just facts of life. If you're going to take the good that comes with these massive commercial drivers, you also take the downside and the concerns and the vulnerabilities that come with it. And that broad and deep globalization is, I think, the second major factor that really shapes the context for our investments in new technologies. And that is just a recognition that not just for production, but for design, for R&D, for education and training, and for the technologists themselves, these capabilities are highly globalized and continuing to become more and more globalized. So what do we do about all of that? Well, first and foremost, our job is to make sure that we, in our military systems, are the best user in the world of globally available technologies. And when we can add to what is available to all parties, if we can add to that some of the unique niche capabilities that we develop here, that gives us an opportunity still to have differentiation in terms of the use of these technologies. At the same time, we need to continue to do what DARPA has done very effectively across 5 decades, which is continue to catalyze the development of new national technology capabilities, going in full recognition that where there are big commercial drivers, these too will be industries that globalize, but also recognizing that if we get a differentiated advantage for 5 or 10 or 15 years, that edge is a huge difference in terms of national security capabilities, and that's still very, very valuable. So we're continuing to pursue those new technological capabilities for the nation in the same way that we have throughout history at DARPA, which is to actively look across a fertile research base. A lot of that great research that's bubbling out there will simply continue to be great science, but in a few areas, we see a kind of fertile work going on that tells us that it's a place to start thinking about building technology capabilities. And where we see that, we continue to make investments in building the radical infrastructure, the tools and the techniques and the communities that can really take that scientific research and turn it into a powerful technology capability for national security needs, because that's our core mission, but often when we create that radical infrastructure, it's available for a whole raft of other public needs and commercial needs. And those have been great stories in material science and across information technology and electronics. We think there are new opportunities of that sort looking forward. And then finally, the other technique that is vital in new technologies, but I think really broadly across DARPA, you can show the world a lot of papers, and people who are in the academic and technical community will go read papers. But the thing that really shows people what's possible and triggers their imagination is when you demonstrate what that new technology is really going to be capable of doing. And so those demonstrations are another vital tool for us to do our jobs. So let me give you a few examples of some of the new things that are bubbling here. And let me start with a program called DAHI, Diverse Accessible Heterogeneous Integration, which you guys will probably appreciate that title, but a lot of people don't actually know what the heck we're talking about when we say all of that. What we're talking about here is an approach that we've been working on with the technical community that lets us really combine the best of globally available silicon technology with its massive integration capabilities for logic and memory, with the huge economics that provides. But to add to that, by intimately coupling and interconnecting components that do the specialized functions that matter for so many of our defense systems, so optoelectronics components or RF or power components, MEMS components for sensing and actuating. When we get this kind of intimate connection so that we really can unleash the power of both technologies, the silicon and the more niche specialized technology, when we can combine them together in these kinds of new ways, we're starting to see classes of devices that we're able to build that neither technology could do by itself. And so it's really a way to get at the best of both worlds. And here what we're working towards is both building specific devices and demonstrating them, but also building the manufacturing infrastructure that will turn this into a capability that we can use for national security purposes. A couple of very interesting examples where we see big opportunities for building this radical infrastructure for new technology capabilities going forward. One has to do with what we're starting to see in the area of synthetic biology. And of course, you know, people have imagined for a number of years what's going to be possible as we fully harness the power of genetic engineering and using cells to produce all kinds of interesting materials. Of course, chemicals and fuels and pharmaceuticals have been the natural place to start. But out beyond that, people are able to imagine and in some cases are starting to build new classes of polymers or catalysts, materials that have properties that we haven't really ever been able to produce before. And even beyond that, perhaps structures, beyond just bulk materials, structured systems that can do a whole host of different things. I think, you know, it's been a place where our imaginations have really been captured. Now, the actual facts of where we are, I think, are a little bit less exhilarating today, but in fact, that's the DARPA opportunity. These things are possible today, but really only at a somewhat limited scope in terms of the complexity of the kinds of things that we're able to build today. And even to do fairly simple things takes many, many years and many, many, many millions or tens of millions or hundreds of millions of dollars of really to make one of these new kinds of capabilities come to life. So DARPA has begun a small effort that we're working to expand. The first program in this area is called Living Foundries, and its objective is to do two things. One is to reduce the time and cost for doing this kind of synthetic biology work, but also, secondly, to be able to expand the complexity of what's possible with our new tools and capabilities. And I think if we're able to do that, we'll start building the infrastructure of tools and techniques and the people that really have the expertise to start bringing some of these dreams to life. Another area, which I think in many ways to me represents a huge potential for a next chapter in a long information technology story at DARPA and with a broad and wonderful IT community across the country, has to do with the opportunities in big data. This is a term that lots of people use to mean lots of things. The DARPA story in big data really began with a very specific on-the-ground military capability that we went in to try to help with in Afghanistan. Classic big data questions where we had immense numbers of bits, but it wasn't really clear what the information, leave aside the wisdom, was in all of that. And as we looked across many different kinds of data sets and started seeing how we might combine and discern real patterns out of that, some very interesting results emerged that we found very encouraging. So then we said to ourselves, well, great, is that just, you know, what happens when a few smart PhDs start mucking around with data? Or hopefully, is this a place where we can, again, start building tools and capabilities that have the ability to scale far beyond any one specific problem? And we became convinced that, in fact, there was quite a significant opportunity in this area. And so the X-Data program is one in a series of things that we're doing that really are about building a much broader set of tools, engaging a broad community. And I think this will be, I think this is going to be another very fruitful area for us. Let me finish this section by talking for a moment about some very early results that are coming out of some work initially in a program at DARPA called Revolutionizing Prosthetics. This program began when one of our program managers, Jeff Ling, who had been a doctor in the Army until just very recently, Jeff was deployed and saw what happened as our wounded soldiers came in having lost limbs. He saw that in theater. He came home determined to create a different way to restore function for our wounded warriors. And he began the Revolutionizing Prosthetics program with a couple of pieces to it. One was to develop a very sophisticated robotic arm that would have function and capability and a level of control well beyond the kinds of prosthetics that are available today. The second part was to learn how we could connect that prosthetic directly to brain signals from a wounded warrior. And over time, as that research developed, we eventually reached the point that we were at a stage where we thought a human trial was possible. And a brave and wonderful woman named Jan, who has been a quadriplegic for over a decade, volunteered to have the surgery done. She's had now a couple of pea-sized implants placed on her brain. And I'll show you this video. You can see what happened. But at the time of this video, it's a few months later after she's had these brain implants. And you'll see now what she's able to do.
5 months after the surgery, we came back to see whether she would be able to control the robotic arm with nothing but her thoughts. They plugged her brain into the computer, and this is what we saw.
I can move it up and straight down and left and right and diagonally. I can close it and open it, and I can go forward and back.
That is just the most astounding thing I've ever seen. Can we shake hands?
Sure.
No, really.
Yeah.
Like, come right over here?
Yes, you come over
Okay.
there. Let me grasp your hand there. There we go.
Oh my goodness. Wow.
And I can do a fist bump if you'd like.
That's amazing. What are you doing, Jan? What's going on in your mind as you're moving this arm around? What are you thinking?
Okay, the best way to explain it is raise your arm.
Uh-huh.
Go. Now,
Right.
what did you think about when you did that?
Well, not very much. I do it all the time.
Exactly. It's automatic.
Is that hard work? Are you having to concentrate?
No, it was hard work getting there. I struggled greatly to go up and down at the beginning. Now up and down is so easy, I don't even think about it. Side to side, don't even think about it.
Just like
that.
your arms used to.
Yes.
So if you're like me, my first reaction was how amazing Jan was to undertake this work. My second reaction was amazement at the sophistication of control and her ease of control. And then I thought, that's really great. And then I thought, wait a minute, this door just opened and my imagination started running riot. Is your imagination running riot? And I think this is a great introduction to a topic that I believe is important for a lot of the technologies that we're working on. Revolutionizing prosthetics, big data, engineering biology, space policy, all of these are examples of things where the work that we're pursuing, because of the technology's capabilities for the future, also puts us in a position where we end up being often the first people to stumble into these much broader societal questions about what these technologies will mean. And I think that's natural, given that this is where we live, this is what we do. Our role at DARPA, there are two implications for us. The first is we actually have to go look at these areas and drive these technologies and understand their capabilities, because that is our core job. That's what we do for our country. And the investment in DARPA is made understanding that we believe as a nation that it's better for us and our national security if we get there first and we think these things through first. So we have to be sure that we are not shying away from these areas, even when they are uncomfortable. But what goes along with that is a second responsibility, and that is the responsibility to raise these broader societal questions, be they ethical questions, legal policy questions, safety or security questions. Not because we're going to answer these questions. I actually don't believe that it's even appropriate for technologists or just people in the defense community to tell us the answers to these questions. Our job is to engage the broader community that is going to be grappling with these questions in the short term, but I suspect in many cases over the long term as well. So what do we actually do at DARPA? Number one, we work very carefully to know what the laws and regulations are that govern the work that we're doing, whether it's privacy or animal testing or human subject work, and we work rigorously within those laws and regulations. Now, that's actually the part that's easy, because you can go find those laws and regulations. Where it gets interesting is when we're in uncharted territory. And here, our objective is to actively seek out and engage experts, but also people with a diverse set of points of view, people other than us, not just technologists, not just people from the defense community, and again, just to engage that discussion. Often, we find that when we start those conversations, we in our performer community can often find technology answers to some of these challenges. So, kill mechanisms in cellular processes that can become ways of controlling synthetic biology processes, or ideas that are technically solid and technically viable ideas for structuring policy solutions to some of the challenges that we're going to face. So we want to be part of creating some of those solutions, but again, at their heart, these are societal questions, and when we go after a technology, our job is to say yes or no. When we raise these kinds of issues, our job is simply to make sure that they're being addressed. We simply can't own the job of saying what the answer is, and I think in many cases, the broader society is not going to know what the answer is, because these can be very complex questions. So this is an example of something that cuts across many, if not all, of our programs, especially the leading edge technology programs. Another aspect that cuts across all of our programs is thinking about where our products, where our technologies go after DARPA is done investing in them. Our job really is to show people what's possible, because we want ultimately to create a revolution in capability. And as all of you have been involved, many of you in this room have been involved in these technological adventures, and you know that it's often a very long journey from seeing what's possible to actually changing the world. Our focus on transition is about making sure that the first step gets taken so that things can keep moving forward. And that happens in a variety of different ways. When we're developing a military system, often we do a demonstration that is mature enough at the end of the DARPA process that it can then roll into a formal program of record within one of the military services. When we're building component technology, it's sometimes a little bit more convoluted path. Sometimes one of our performers will come up with a new component capability that we help fund, and then later a major defense contractor will subcontract for that element that finally gets integrated into a bigger platform. Sometimes, as we discussed before, our work leads to commercialization, private capital that's invested to build companies or products, and then that becomes commercially available technology that the Defense Department can reach out and pull in for its applications. And then sometimes, because so much, a good fraction of the work that we do is still at a fairly early developmental stage, sometimes the natural next step is just continued development. So all of those are ways that we think about transitioning our technologies. These are 4 examples: MainGate for communications, Halo for high-resolution imagery. Transapps is taking mobile applications that we take for granted, taking those into the austere warfighter environment. And blast gauge is a small device that helps understand what injury a brain has been exposed to in a blast situation. These are 4 examples of technologies that we have taken to the field in Afghanistan and have gotten into the hands of the warfighter, which is terrific because we're making a contribution to some of the real issues that we're facing today. But for us, really, we hope it's just the first step to a much broader transformation over time. I've told you about a lot of the things that we are investing in and our hopes and dreams. Obviously, in the work that we do at DARPA, because we're trying to take big steps in capability, inherent in that is taking on often quite significant technical risk. And so how we manage these programs and the projects within them is also really critical to our success. I think this is a challenge all of us who are in the business of managing research and development share. We're aiming for long-term results, but we have to measure and assess and make management decisions in the here and now. And one of the things that is built into the way DARPA does business that's helpful for us is our programs nothing lasts forever. A program that we commit to funding has a start date and it has an end date. And we at the end of that time, we may choose, if it's a successful fertile area and there's a great next step to take, we may choose to continue or to do the next program in that area, but we may quite equally choose to move our resources into a different direction. And there's no automatic continuation, and that really does help force the thinking about when to stop, which I think is critical. But while programs are running, program managers are very active in managing within their programs. The technical leadership in the agency manages across the portfolio. But the questions we're always asking are, how do we set the right milestones? How do we assess progress against those milestones? And then when we're not making progress, how do we rejigger to get the resources in the place where they're going to do the most good? And ultimately, as I'm sure all of you have struggled with all of these issues throughout your careers as well, at the end of the day, we succeed if we strike the right balance between that kind of tuning and tweaking and moving resources around, balanced against giving our performers the time that they need to make progress against pretty challenging objectives. That's what DARPA programs are about. So that's the day-to-day management challenge, and at the end of the day, it's about judgments, hopefully informed with a lot of first-hand data, working directly with companies and universities. Let me just touch briefly on the third objective in my list, which is about keeping DARPA itself healthy. I've talked about how critical the role of our program managers are, and that really is where this story starts. These are people that we bring into the agency typically for a 3 to 5 year tour. We look for people who have a set of characteristics. Obviously, they need to be technically very, very strong, very capable. But we also need, along with that, people who have dynamic range and can go from deep technology to understanding what difference it makes, to navigate that up and down, communicate that clearly. We're looking for people who have the drive and the spirit to work with a broad community, cast a vision for a program, sell it to raise the resources internally that they need, but then project that vision to a large community and rally people around seemingly impossible goals. And then as those communities start building and the programs start building, we need people who are able to take those results and help get them out to users or the people that are going to take the next step and be part of selling those great ideas forward. These are special people, but every time we bring one of them in, the promise of that new individual coming in the door and what they're going to be able to do is that's the most exciting thing that happens at DARPA. All of us who are in the technical leadership organization focus on hiring those people and empowering them, making sure that they can do their jobs. And then our job is to take the program ideas that come from our program managers and from those to define a balanced portfolio that's diverse, that thinks about these elements of context I've been talking with you about today. The rest of our organization, besides the technical team, is as mission-driven And they are a big part of the reason that someone can come into a government agency in 3 to 5 years and actually get a lot done. We've also been very fortunate to have support from Congress to have hiring and contracting authorities that let us do business in a driven, fast, move at the pace of technology kind of way. And then these first 3 boxes are what happened inside of our own 4 walls. No technical work that changes the world happens just inside of any 4 walls, certainly not ours, and it's really because we can engage this vast technical community that has companies of all sorts, universities of all sorts, people from across the government, DoD, but also other parts of government. That's key to our success, and then with that, working typically with the services and other defense agencies, both to help manage our programs on the technical side, but then ultimately to help carry them forward. Those engagements are key to our success. When all of that works, all of that machinery is really humming along, then that allows us to continue to build and reinforce a culture at DARPA that is unique. And it's a culture that is driven for off-scale impact. It's a culture that's willing to take risk and work very hard to drive the risk down, and even willing to fail if that has to happen, because we know that that's part of taking big steps. And it's a culture that just recognizes what a privilege it is to work for our country to try to create a better future. And these are the things that we talk about on Mondays when we're looking at new program ideas, but they're also the things that we talk about in our hallways, and those are the things that make DARPA the place that people run in to work, because we're going to really make a difference. And we do this in partnership with a lot of people in the technical community, and I want to thank you all for being part of that with us. Thanks for your interest in DARPA, and I'd be very happy to try to answer your questions or hear your comments. Thanks.
We have time for several questions. I think you'll entertain. We have 2 microphones. Raise your hand and have the microphone come to you. Also, state your name, whether you're a member of the society or not. Let's start with the back first. Anybody in the back? Okay, let's start with, let's see, there's a gentleman, down there.
Hi, my name's Greg Glore, and I'm a member. I have a question about the ideas. Where do they come from? Do they come from the industry side? Do you invent them yourselves? Does somebody in the defense community suggest these to you? Do you have the final say on which ideas you pick up and run with? And what's your email address in case I have anything I want to send you?
And what was the rest of that?
What's your email address in case I have some ideas?
That's really easy, because that's just arati@darpa.mil. I was gone for 20 years, and it was so fun to come back and get the same email address again. The answer to every one of your questions is yes. Some of our ideas come from people in industry or universities. Some come from our program managers. Some come from people who have defense needs that are very, very compelling. So, open aperture, because I think all of those are places that we always want to be mining for ideas. The program manager is the person who pulls all of that together. And I have program managers who came to DARPA because they had something they really wanted to do where they were before. Everyone told them they were crazy. No one's ever going to put money into that. We went and got them because we wanted to try that crazy thing. So they brought their own idea. Now, really great program managers, even if they've done that, will go out and talk to everyone on the planet, because you're at DARPA, you can talk to all the people, anyone, almost anyone will talk with you, and you can tap into a much broader set of creativity than just what's bubbling in your own head. So we have people who still are the core of their own program ideas. We have others who came in with a broad background and went and looked for big opportunities and cobbled something together because they were inspired by talking to 10 people across 4 different areas. And occasionally someone in the Pentagon will say, we have this impossible problem, an immediate one or a future one, and we'll start knitting our brows and thinking about it, and it'll turn into a really interesting program. So sources can be many. the next question you asked was, do we get to decide? And I'm really pleased to tell you that the answer is yes. It's really good.
Hello, ma'am. How you doing?
Hi.
Thank you for your speech, or your brief. My name is Gary Thomas. I'm a staff engineer for the Department of Defense. My question is, what are your thoughts on the on Moore's law and its future?
One of my office directors at DARPA is a fellow named Bob Colwell, who was the chief architect on the Pentium at Intel Corporation in the late 90s. And Bob Colwell is trying to explain to people that after all these years that we have come to just believe that Moore's law is sort of like, a law of physics, that it's not, and that it's actually going to end, that it's in the process of ending. That's actually going to have some very interesting repercussions. I think, just today I was in a briefing where someone said this problem was, 8 orders of magnitude too slow. And someone else said, well, that's just a matter of time before we'll have the computational capacity to do that. Well, it turns out if Moore's law actually slows down and ends, that you can't simply wait for every problem to become computationally tractable. So I think we're going to have to get smarter again about what the other things that we do. So I do think that's a very interesting question at this point. We have a couple of programs that are thinking about new architectures, new processing techniques, ways to do special purpose processors that can keep pushing capability. But that is not the same as the next Moore's law, which I think is, our worlds are going to change because we've gotten spoiled.
You mentioned on the, David Bell, I'm a member of the society. You mentioned on the Phoenix program that the application would be harvesting resources from satellites that are dead in orbit. But it seems like the defense application would be going to other, say, potential enemies and disabling their satellites and harvesting their resources.
Your imagination was wild, right?
Do you anticipate any sort of reaction to that program in technologies that would be created to counter that?
Yeah. That is precisely why we wanted to make sure when we started that program that we did it in the wide open. We've gone out of our way to not just tell people we're doing the program, which we usually do because we want to engage performers, but here we've gone out of our way to put together, videos that show how we imagine almost like an air traffic control-like situation, right? Where our satellite is cooperating with the operator of another asset, and we're working together to do something remotely in space. Because we think this is actually, we think, a terrific opportunity to set not just our activities, but the global way of thinking about this on a path to a future where we can actually think about those kinds of space servicing and refurbishment kinds of applications. So obviously, almost any of these interesting new capabilities can be used for good reasons and for bad reasons, but this was an area where we wanted to really take the initiative and get it out there in the open. And by the way, despite that, I think it raises a lot of hackles. It's, I think everyone sort of goes, wait a minute, we're doing what in space? So it's a very worthwhile question.
Stuart Reuter with the Navy League and a member. There was a program called the Future Soldier or the Future Combat System within the Army that was recently abruptly defunded. Was that something DARPA was in on the beginning of?
Yeah, I don't know the details because that happened in that vast tract of time during which I was not at DARPA. But as I understand it, FCS did have a number of its roots back in earlier DARPA programs.
Hi, that was a great talk. I'm Ivan Amato. You were once my boss
Ivan.
at NIST. Hello.
Oh.
Very interested in your experience in many institutions now and looking at culture. So I'm wondering if you can share with us perhaps, I'll give you just a number, two must-dos in a technology culture that will work or that will help that institution work, and two things that they must avoid. Or whatever number you want.
Okay, well, I'm probably not going to answer your question, but I want to use it to talk about something I think is really interesting. 20 years ago, I went from DARPA to NIST. And I feel so fortunate that I have gotten to serve at these two truly stellar technology organizations in our government. And I have to tell you that they couldn't be more different if they tried. And so I think actually, to answer your question, you have to start with mission. What I found when I left DARPA, I was a person who had spent her entire, my formative years were at DARPA, and we ate, breathed, lived risk, and we thought life was about getting out of bed in the morning to go take risk, to take big steps. And I got to NIST, and the first time I said risk, everyone around the table whose job it was to get the next decimal place of accuracy looked at me like I was insane. And they said, risk? They said, careful. Careful is the right word. Get this straight. And they finally educated me, and it all turned out fine. But, really, I think culture does derive from mission. And those are two very different organizations that have wonderful cultures, but really quite different ones, reflecting different missions.
Does DARPA work with the defense treaty? It used to be called DTRA, Defense Treaty Threat Reduction Agency.
DTRA.
DTRA, yes.
We do. In fact, one of the things. So there's been some historical examples of DARPA investments around biodefense in particular. That over time I think have had some good transitions with DTRA. One of the things I'm personally interested in is taking a fresh look at the challenges in counter WMD, and just to see, there's so many people who are working hard on many aspects of that problem, but I thought it was a worthwhile thing to take a fresh look from a DARPA perspective and see if there were opportunities that where we could make a meaningful contribution. And in doing that, we've been spending a little bit of time more recently with DTRA folks to just understand the landscape and what they see as challenges. It's been a good conversation. Do you have a specific suggestion on that?
No. Did you ever work for DTRA?
Did I? No.
Claudio Cioffi, George Mason University. I am a member here. Around the time when you became director, there was a change in the national military strategy, which elevated humanitarian assistance and disaster response operations to the same priority level as combat missions. And I wonder to what extent has some of this begun to have an effect on programs and priorities within your own agency?
A couple of answers to that. A very specific answer has to do with the current DARPA Robotics Challenge, which is focused on humanitarian aid and disaster relief scenarios. The challenge that we're running currently asks any participant to build a robotic capability to deal with a human-engineered environment. And what we're imagining is a Fukushima-like situation where a robot would be a great way to solve problems in places where humans can't go. But you're dealing in a human-built environment, so you want to be able to climb something that can climb stairs, turn knobs, those kinds of functions. And I think I think it's a very engaging and very interesting challenge. A little bit broader answer to your question. DARPA really was created in order to think outside the box of the current requirements-driven process in the Defense Department. And so while we certainly, as I hope I've tried to convey, we try to look broadly at the world and what we think the issues are, not just now, but really in the decades ahead, because we really view our job as being the place in the department that thinks about where technologies need to go in that time frame. And as a consequence, while we are aware of and sometimes get engaged with the more, the sort of day-to-day shifts in emphasis, really our job is to maintain a little bit longer view. And, I think if you keep that perspective, it drives you to a set of technologies that are broader in many instances than the specific tasks we're dealing with in the department at one moment.
Hey, I'm Loki Jacobson with Thetis Corporation. Not a member. You mentioned you work with a wide range of sizes of companies, all the way down to individuals in some cases. With the increasing complexity of technology, do you see a change in where the trying to think of the word, sorry. Do you see a change in where the development is happening from smaller to, going from the smaller organizations to the larger ones? And do you see some sort of thing in the future with the direction that that's going?
Yeah, I think that's a great question. And I think the answer probably is more meaningful if you think in a particular area. So one example, of course, is in cyber, where if you only work with sort of the classic defense community, you're simply not participating in a set of conversations and capabilities that's rich and growing, and has a vast number of other players. So DARPA's done some great work in the last few years, both in terms of who we've brought in as program managers from the broader hacker community, but the programs that they've run, the outreach that we've done, because we absolutely have to tap into people that are well outside the conventional bounds in that particular instance. And I think, so, that might be, if you like, a trend, because that's a particular area. But generally speaking, I would say I think there's at any moment in time in every field that we do need a mix of different kinds of companies. At the end of the day, we need, we often are very dependent on major defense contractors if we're going to end up building the kinds of systems that the DoD is going to be able to procure. But what feeds into that is work from all different types of entities, as you said, all the way down to individuals. So I see it as this sort of ecosystem. And now what I think is interesting in terms of DARPA operations, it's really easy to sit in our building and just sort of see who shows up, because a lot of people show up and we get to see a lot of ideas. But again, really great DARPA program managers get out of the building and they go find people that don't know or don't care, right? And go engage them anyway, because that's how you're going to come across some of the capabilities that are a little bit more interesting sometimes than the people who already know to come get engaged.
Eric Enig with Enig Associates, and also a member. So towards your point, the gentleman mentioned DTRA. We have a small program with DTRA that was actually the result of a DARPA program manager out of Tactical Technology Office going out of DARPA and briefing other program managers in the different services that led to them learning about a capability and resulted in a small program. So my question is, you mentioned these program managers are here for 3 to 5 years, and as a result, and part of their mission is to do transition. Sometimes, they come in with a portfolio, sometimes they're brought in and they inherit other important programs, sometimes they run their own new starts, but then they leave. And so I noticed on one of your slides you have a timeline depicted there where you show things like reconnaissance, surveillance, unmanned systems, and there are these long stretches in the timeline. Then there's a big gap, 10 years, 20 years, then they come back. So my question is are they coming back to DARPA because there's new national technology development, or was there bad transition with the service or commercial, or is it a little bit of both?
Well, that chart was the good news stuff, right? All right, that's the stuff that worked. So those obviously were good transitions. But really what I was trying to convey was that in an area, for example, like navigation, you have many generations, and DARPA goes in when we see a big opportunity. And we have the luxury of not covering the waterfront. Our responsibility is to see the things that people aren't covering in the waterfront. So I think it's very natural that we will go in and out of areas like that because of that moment in time where we see the big opportunity.
Hello, my name is Dr. Rudolph A. Krutar. I am a member of the Society, and I appreciate that DARPA supported projects at Carnegie Mellon Institute, Carnegie Mellon University in the early 60s, late 60s, early 70s, that got me through graduate school.
That's great.
Now, you mentioned...
Too, that's how I went through graduate school, too. Just
you mentioned the global positioning system at the start and several times throughout your speech. Now, a friend of mine, Scott's father, Tom McCaskill, was the first person to solve the instantaneous positioning problem. He participated in the early demonstration of the possibility, the feasibility of navigating by satellite timing. And he's the only person I know who actually designed a constellation that's in the sky.
That's awesome.
Yes.
That's great.
And he qualified every clock that was on the NAVSAR satellites until he retired 10 years ago. So he did a lot of technical work. Now, I believe that GPS is worthy of Nobel Prizes in peace because of the reduction in number of civilians killed in attacks, in physics because it verified Einstein's equations.
You have a question?
Yes, I do. And
is that a requirement here?
And in economics...
It's better to have a question, yes.
I will get to it.
I don't care. Okay.
And in economics because of the vast money it has saved a lot of institutions. Now my question is, yes, there is a question.
Thank you.
Is there any feasibility of technical people getting rewarded for their work on GPS?
I don't speak for the Nobel Committee, that's for sure. Well, I would hope that there would be recognition, and I think there has been quite a bit of recognition for these kinds of immense contributions. You know, I don't know how to do the Nobel Prize, but I think I would hope that do you feel that we haven't, as a community, really recognized those particular contributions? Well, maybe the Philosophical Society should do something about that.
We don't give Nobel Prizes, unfortunately. Okay, let's move to the next question.
Hi, my name is Sean Usman, and I'm a project scientist with the National Geospatial Intelligence Agency, not a member. My question is, how has DARPA changed for better or worse at your time when you were a project manager to now? And how do you foresee it changing after your tenure?
Well, as you might imagine, I thought about that a lot because when I came back to DARPA last summer, I'd been gone 19 years and had not really done much at all with the agency in the time that I'd been gone. Actually, I hadn't been really connected very much with the defense community at all. So I walked in wondering exactly that, and I'll tell you, it has changed in some very interesting ways. My main observation would be that when I worked at DARPA 86 to 93 was my first tour, DARPA used to be sort of like a kiwi fruit. You know, we were sort of brown and boring on the outside, and then inside was crazy and green and vibrant and sort of zingy. And now I think DARPA is not a secret anymore. And you know, even outside of the technical community, it's a known entity, or at least some, you know, a name that people recognize. And that's good. I mean, it helps in some ways. It helps recruiting. It helps us reach communities that normally wouldn't be thinking about working with the Defense Department. Those are all good things. But, you know, taking risk and doing things that, our job is to do things that aren't obvious to a lot of people. And when you do that in the goldfish bowl of 24/7 news coverage, you know, that's not always the best way to do things that can give you big leaps forward in progress. So in a sense, I think we have to work harder to make sure we're not hemmed in by that. But, you know, like most things, it's got two edges. But that's sort of how I think it's seen on the outside. The thing I was thrilled about when I came back last summer was that despite the fact that the world is different, we're in a different building, every program manager is different, technology is different, it's the same culture. You know, people are just running into work in the morning because they have to get their work done because they got to change the world, and you know, they're just like this all the time, which is fantastic.
Time for our last question. Go ahead.
My name is Paul Gaillet, a non-member. I worked in the cellular phone industry about 1980, and a few years after, when it was in its infancy. And I priced systems too. What we ourselves kind of figured out, and the big marketing men in the system said, eventually we'll have 2 to 3% penetration. So it was something, completely overlooked. I guess Moore's law had something to do with this, and ingenuity. But now, there's two things that I see people keep talking about for power, which is wind power and solar power. And I don't see any great future for wind and solar power because there's only so much wind and only so much sunshine. And I wondered if you would agree with that. And do you see something now that's could make a great transition like cell phones did?
Why do you think there's not enough wind or not enough sun? Or is that like the 2 to 3%?
Well, there's so much radiation from the sun, and we know how much it is, so you can figure out how much land it's going to use up, things like that.
Well, not to get off in the weeds on energy things, but it's hard to imagine any energy future in which the majority of our energy sources is monolithic, right? I mean, I think we need many, many different types of energy sources, and so I actually am much more bullish about the prospects for those two technology capabilities. But the broader question you're asking is, what has that future possibility now? And I'm tantalized by some of the things that I showed you here in terms of big data is an example of a technological capability. Right now, when companies talk about it, they talk about mining data to do better consumer marketing, and it feels like a really powerful technique to them. But I'm really sure that within 10 years, that will look like they were in kindergarten compared to what we're going to be able to do. So, there are places like that where it's very easy for me to see how technically and also in terms of applications, our abilities are going to grow astronomically. And I think as a consequence of that, those capabilities will touch everybody beyond how they already do today. So I don't know. I think there are lots of examples like that, but it's hard to look in the crystal ball. We'll just go build these things.
Well, thank you very much.
Thank you.
In appreciation of your lecture this evening, we have the announcement signed and framed, and signed by all the members of the General Committee and framed for you to keep.
Very nice. Thanks very much.
You're welcome.
Thanks.
Thank you.
Yeah, thanks for the chance to do it.
Dr. Prabhakar, can you hear me now? Yes. I'll speak louder, I guess, maybe can overcome. Can you hear me now? Okay, thank you. Dr. Prabhakar will be here during a social hour. I'm sure there'll be more questions, but she'll be around to answer